Chapter 3, Section 2, Proof and Perpendicular Lines. The theorems in this section say, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. If you think about a linear pair, we know that the angles have to be supplementary. So if two angles are congruent and forming a linear pair, they have to be forming 90-degree angles, which two lines that intersect to form 90-degree angles are perpendicular. The second theorem says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. If you think about two adjacent acute angles, that means two angles side by side. And if two of the sides of the angles were perpendicular, that would mean that the two smaller angles would have to add up to equal the larger angle, 90 degrees. If two lines are perpendicular, then they intersect to form four right angles. Because these theorems do not have names, we are going to have to write what they are when we're trying to use them in a proof. We've talked about some, like the angle addition postulate, for instance. If we're using that in a proof, we can just write angle addition postulate. But since these do not have names given to them, we are just going to have to rewrite them in our statement. This example asks us to write a two-column proof. We're given that BA is perpendicular to BC, and they're asking us to prove that angle 1 and angle 2 are complementary. Take a second to look. If you look, BA and BC are perpendicular, so that's meaning that this full angle, angle ABC, is 90 degrees because the two lines are perpendicular. If you notice, angle 1 and angle 2 are two adjacent acute angles that are forming angle ABC. So we should be able to say that they are complementary. Remember, we always start a proof with what we're given. So we're given that BA is perpendicular to BC, and the reason is given. Now, because angle BA and BC are perpendicular, I can say that angle ABC is a right angle because of the definition of perpendicular lines. Perpendicular lines form four right angles. Now that I have angle ABC as a right angle, I'm trying to get that angle 1 and angle 2 are complementary. Being complementary means that they're going to add up to 90 degrees. So I'm going to go ahead, and because angle ABC is a right angle, I'm going to go ahead and say that the measure of angle ABC equals 90 because of the definition of a right angle. Now I'm going to use the angle addition postulate because angle 1 plus angle 2 is equaling the angle ABC. And that would be the angle addition postulate. I'm getting really, really close to proving angle 1 and angle 2 are complementary. I have angle 1 plus angle 2 equals the measure of angle ABC. I'm going to use that the measure of angle ABC equals 90 degrees and plug in 90 for a measure of angle ABC because of the substitution property of equality. Now if I have the measure of angle 1 plus the measure of angle 2 equals 90, that does mean that angle 1 and angle 2 are complementary. So I can go ahead and say that angle 1 and angle 2 are complementary because of the definition of complementary angles. If two angles are complementary, then they're adding up to 90 degrees. The next example asks us to write proof of the congruent supplements theorem. Now, something to point out is that when I'm trying to prove the congruent supplements theorem, I am not going to be able to use the congruent supplement theorem in the proof that I am writing. So we're trying to prove here that angle 1 is congruent to angle 3. We're given that angle 2 equals angle 4. Angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. Remember, I'm always going to start with what I'm given, so go ahead and rewrite these givens and put the reason is given. Now, if you look at what we're given and look at the pictures up above, angle 2 and angle 4 are going to be equal angles. Angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. If we were not trying to prove the congruent supplements theorem, I could actually use it right now and say that angle 1 is congruent to angle 3. But since we are trying to prove it, I cannot use it. If you know that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4, there is something more that I can say. I'm going to go ahead and say that the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 3 plus the measure of angle 4 equals 180 degrees. This is just the definition of supplementary angles. If two angles are supplementary, they add up to 180 degrees. Now that I have the measure of angle 1 plus the measure of angle 2 equal to 180, and the measure of angle 3 plus the measure of angle 4 equal to 180, I'm going to set the measure of angle 1 plus the measure of angle 2 equal to the measure of angle 3 plus the measure of angle 4 because of the transitive property of equality. Because both of those statements above were equal to 180, I can get rid of the 180 and set it equal to each other. Because I am going to notation and I'm going away from numbers, I'm going to say that it's the transitive property instead of substitution. Now that I have the measure of angle 1 plus the measure of angle 2 equal to the measure of angle 3 plus the measure of angle 4, look up above to the very first statement that you wrote. It says angle 2 equals angle 4. Well, notice I'm adding angle 2 on the left side of the measure of angle 1 plus the measure of angle 2, and then I'm adding the measure of angle 4 to the right side where it says the measure of angle 3 plus the measure of angle 4. If I get rid of the measure of angle 2 and the measure of angle 4, notice that I have the measure of angle 1 equals the measure of angle 3. And I can get rid of them because of the subtraction property of equality. I'm subtracting two things that are equal from both sides of my equation, which keeps the equation equal. I'm really, really close to proving that angle 1 is congruent to angle 3. I have angle 1 equal to angle 3 right now, but remember that doesn't work. I need to go ahead and set them congruent to each other. Because of the definition of congruent angles, I can do that. If two angles are equal, then they are congruent. Today's assignment is on page 139, numbers 11 through 16, 19, 24 through 27, and 29 through 36.